Hello everyone, welcome to today's class. Today we will be talking about program data. In the world of programming, understanding the nature and the structure of data being processed is very necessary. Whether you are starting out or looking to deepen your knowledge, this tutorial would help you with the foundational understanding that you need. In this comprehensive guide, we will cover exactly what a program data is and why it is necessary for every programmer to understand. The different types of data encountered in programming, from single variables like integer and characters to group items such as arrays. How program data is utilized within an algorithm is also one of the things that we would cover. And then we will look at real-world examples and practical demonstrations to solidify your understanding. By the end of this video, you will have a deeper understanding of the significance of program data and how it influences the design and the functionalities of your program. Whether you are embarking on a career in software development or simply exploring the world of coding out of curiosity, this knowledge will serve as a solid foundation for your journey. Don't forget to subscribe to our channel for more insightful programming tutorials and hit the notification bell so that you never miss an update. Let's dive into the fascinating realms together. But before we do, let us review the assignment from our previous videos. I'll put the link in the description below. Please do well to watch that before this one. Now to our question. The question states that a program is required to read from the screen the length and the width of a rectangular house block and the length and width of a rectangular house that is built on the block. The algorithm should compute and display the mowing time required to cut the grass around the house at the rate of 2 square meters per minute. Let us try and understand what this question says. What the question simply is requiring us to do or is telling us is that there is a rectangular house block. Let us refer to that as our plot of land. So there is a plot of land which is rectangular in shape, and then on that plot of land there is a house which is also rectangular in shape that has been built on the plot. And so all that your application is to do is to calculate how much time it's going to take to read around the house. So let's see how we can do this. So let us assume that the bigger rectangle is the block, right? And the smaller rectangle is the house. So there is the house block and then there is the house. So your application is supposed to calculate the area that is shaded in green, how much time is going to take to read that portion, the portion of the rectangle that has been shaded green. So first of all, like we saw from the previous video, whenever we are given something like this, we first need to draw our definition table. In our definition table, we are going to identify what are the inputs and what are the output. Let us go back to the question and see. So from the question, we see that they said the program requires to read from the screen the length and width of the rectangular house block and then the length and the width of the rectangular house. And so we see that the input would be both the length and the width of the block and the length and the width of the house. And then after our algorithm, the algorithm should compute and display the mowing time. So obviously, what our algorithm is expected to give out is the mowing time. So when we go back to our definition table, we will state that the block length and the width length and the house length and the width of the house would be our input. and then the moving time would be our output. So how do we convert from these inputs that we are given into the moving time? Like I've always said, once you are given something like this, always look out for the verbs in the question. The verbs will point you towards a direction which you've been asked to go. So let us go back to the question and see. So from the question, you can see that the program is required to read. So the first thing you are being required to do is to read. After reading, you are being asked to compute. And then after computing, you are being asked to display. So let us go back to our definition table and fill it out. So because we are being asked to read, as a good design, we'll prompt the user to give us the measurement. So because we are reading for both the block and the house, the reading is going to be in two folds. So we'll first prompt the user for the measurements of the block, and then we'll receive whatever the user gives us. Then we will prompt the user for the measurements of the house, and then we'll receive whatever the user gives us. After that, we can see from the diagram that we saw earlier that if we really want to find out the area to be cleared, it will be the area of this bigger rectangle minus the area of the smaller rectangle, right? And so first we need to calculate which area we are going to weed, and then after that we can apply the time. So in our computation, we will say that we will calculate the mowing area, and then from the mowing area, we can calculate for the mowing time. So in all of this, the algorithm would be what? Prompt for block measurement, get block measurement, prompt for house measurement, get house measurement, calculate the moving area, and then calculate the moving time. So as simple as that, we have our solution for this problem. If you have any question or you don't understand anything, please put it in the comment section below and I'll do well to answer you. At the beginning of every program, you, the programmer, must clearly define the form and the type of data to be collected. The data type can be elementary items or made up of data structures. But before we look at the different data types that can be collected, let us look at some very common terms that we will come across once we are dealing with data. The first one we'll discuss would be variables. The next one, constant, and then literals. So, what is a variable? A variable is a name given to a memory cell designed to store a particular item. What do we mean by this? Think of the spaces within your computer's memory as this Excel sheet that you see on your screen. For us to store data here, we can pick a particular cell within the Excel to store data. So for instance, we can store 30 here and store 20 here. But if we have so many of these numbers across the different cells within the Excel sheet, how can we easily identify each of the numbers that we have stored or each of the data that we have stored within the computer memory? In terms of Excel, it is easy to identify using the rows and the column. So for instance, when I say go to cell A4, you pick A4 and then the value there is what? Is 30. The same way, if I need you to pick this value, I'll just say go to cell B3. And so you look for B3 and then you can find the value there. In your computer program, data is handled in a similar way. The data is scattered within your computer memory like what we have on the Excel sheet. And for your program to be able to identify which data you are referring to, you have to give each space or each cell a name. So when we talk about a variable, it's simply a name that has been given to one cell within your memory. where you intend to keep data. In the case of a variable, once you store a value within the memory cell, that value can change. That is why we call it a variable, because the value varies. The value there varies as the program executes, right? And so you can call a space within memory total amount, and total amount can contain several values during the execution of your program. So as and when you get a new value, you can always replace the old value within that space with a new value. So in a summary, what we can say is that a variable is a container for storing values. So one thing you should take note is that a variable can store only a specific type of data. What do we mean by that? Remember, we said a variable is a container for storing values. So think of the container as a wine bottle, right? You cannot store cookies or biscuits inside a wine bottle. And so if you have a variable of the type wine bottle, then it can only store a certain type of data, which in this case may be liquid, but not that of what? A biscuit. Now let us look at the next term, which is what? Constant. When we talk about a constant is similar to a variable. The only difference is that in the case of a constant, whatever value you put into that container cannot be changed during the execution of the program. So for instance, when I start executing my program and I say this space is called total amount, and I put an amount of, let's say, 50 in there, then the 50 cannot change throughout the period which my program is running. Why would you want to do something like this? Let us pick a typical example. So if I'm writing a program for a school, I know that the name of the school would usually not change. And so because of that, I will want to keep the name of the school in a container that does not change, so that somebody will not mistakenly change the name of the school. And that is why sometimes constants become necessary within your program execution. The next term we are looking at is what? Is what we call a literal. A literal is simply a constant whose name is the same as the value. So remember, we said that variables are containers that we put values in. So you have a container, you put a value in it, you give that container a name. That is what we are referring to as a variable. In the case of a constant, we said whatever you put into that container cannot change. In the case of a literal, the name that we put on the container is the same as the value that is inside. So if the value inside the container is 50, then the name of the container is also what? Is 50. In that case, we don't have a difference between the name and the value. Unlike a variable where we can call a variable A, but the value inside can be 50. In the case of a literal, when the value is 50, the name of the container should also be what? 50. Now let us try and understand something. We may come across terms like data types. What is a data type? Let us think of it this way. Remember we saying that a variable is a container that is used to store values, right? So if tomorrow I ask you to come for tea, what type of container are you going to bring? Are you going to bring a basket? No. Why? Because a basket cannot store liquid. Are you going to bring a bucket? No. Why? Because even though a bucket can store liquid, it doesn't make sense to come for tea with what? With bucket. Buckets are too huge. This explains why data types are necessary in programming. Depending on the data that you intend to collect, you need to choose the appropriate container that is used to store this container. And so, whether you are storing integers or you are storing characters, you need to tell your compiler so that your compiler would give you the appropriate type of container to store that particular item, and not a free-for-all show where any container is used to store any type of data. There are two main categories of data types that you may come across. We have what we call the elementary data type and then data structures. Elementary data types are basically a type of data that, that contains single variables that is always treated as a unit. They are usually classified into data types. A data type consists of a set of data values and a set of operations that can be performed on those values. Examples of elementary data types are integers, real numbers, characters, and Boolean values. So integers, like their name go, is used to represent whole numbers, right? Real numbers or the real data type is usually used when you want to deal in numbers with decimals at the end. Characters are used to store single value character. So either A or B or a dollar sign or any other symbol, right? You use a character data type to store that. Then we have Boolean values. Boolean values are used to represent true or false. They have only two possible values, either a yes or no, a true or false, a 0 or a 1. However, there are some containers that are as a result of a combination of two or more elementary data types. These types of containers are what we are referring to as data structures. An example of data structure is a record or a file. An array is also an example of a data structure. An array simply is a data structure that is made up of a number of variables or data items that all have the same data type. So for instance, if I want to store the scores of everybody in this class, you would realize that I cannot use an integer. Why? Because an integer can store only one value. And so if we have 100 students in the class, then I would need 100 different variables to store that. That doesn't make sense. That is why arrays were invented. And so I can create one array, which is one variable that has 100 different compartments that can be used to store these values that I want to store. We also have what we call a string, which is simply a collection of characters that can be fixed or variable, right? And so if I want to store a name, remember I said character is only used to store one character. So if I want to store my name, then I would need multiples of that. And that is why strings were created. And so that I can put my entire name into one particular container and call it what? A string. Whenever you have data, your data should undergo certain checks to make sure that everything is okay with your data that you want to use within your program. What are some of the checks that your data needs to go through? You need to check if your data is of the correct type. Also, we need to check if your data falls within the correct range, right? You can even check the length of your data to see if it is of the correct length. And then you also need to check if your data has all the required fields that should be present. This is what we refer to as checking for the completeness of your data. You can also check for the correct date. And incoming data should be acceptable. Let us recap everything that we've seen in this tutorial. We started by saying that our programs make use of data, and so we need to understand how our data is and how they are processed within our program. We saw that we have three common terms that we always come across: variables, constants, and literals. We said Variables are simply containers that are used to store values. Constants again are like variables, just that their values do not change during the execution of the program. Then we have what we call literals. Literals are special types of constants whose name and values are the same. So for instance, if I want to store the figure 50, then I just write 50 to representing both the name and then the value. From there, we saw that there are different data types within our program. We said data types are simply the different types of data that we would normally use within our program. We saw that we have two main categories. We have the elementary data type, and then we have our data structures. The elementary data types consist of integers, real numbers, booleans, and characters. And then we saw that under data structures, we have arrays, we have strings, and we have files. All of these are different types of data that are used within our program. And then we said that any data that is being used within our program should be validated. They should be validated for correctness. How correct should they be? We should look at the type, the range, the length, the completeness of each data that we intend to use within our program. Well, thank you for staying with us. We hope to meet another time. Again, don't forget to subscribe to this channel for more tutorials like this. Thank you.